All right, so here's our last section of Unit 3. It's going to be radicals, higher roots, and rational exponents. So first we're going to look at the higher roots part. So thus far we've only been doing square roots, and that means our index has been a 2. But now we're going to look at some higher ones. So if you look here at 54, see we have this is called a cube root, okay? And we'll go a little bit higher than that. Here's a fourth root. We might see some that are a little bit higher, but we'll stay mostly around 3 and 4 as our index right there for our higher roots. They can go as high as you want, but like I said, for the most part, we'll try to keep it somewhere around cube roots and fourth roots. All right, and then we'll look at rational exponents. That'll be our part 2 of this, so we won't worry about that right now. Okay, so like we've seen before, so whenever you take the square root of x squared, you would get x, right? Okay, and so what we're going to do now is if you take a cube root of, this time it's going to have to be x to the power of 3, it would nullify the cube power and would be an x like that, okay? Now, we do have to be a little careful here, okay? If you recall in the previous sections, we were not able to square root negative numbers. It was non-real, okay? That is different for cube roots, and more specifically, odd roots. So if you want to take the fifth root of a negative number, that's okay. If you want to take the cube root of a negative number, that's okay. It's not okay for our even roots. For our even roots, that's when we get the non-real solutions, okay? So right here, so that's kind of what I have right here. So as long as the root, if it's even, so if it's a square root or if it's a fourth root of a negative number, our answer right now is non-real. At the very end of my video, we'll talk about the workaround, and it will be fairly basic, okay? But for right now, that's kind of what this is noting. And then there's one other thing. If you are taking an odd root, a third, a cube root or a fifth root or seventh root or ninth root and so on, if the value inside is negative, a nice little workaround is just go ahead and pull that negative to the outside, and then you can kind of focus on what's going on inside, okay? And so we'll see that on number 57 in a moment. So we'll take an in-depth look at that one in just a minute. Okay, so when performing these higher roots, what you'll want to do is probably have an idea of what your perfect roots are. So your perfect cubes, your perfect fourth powers and fifth powers, and so on. Like I said, we'll keep it pretty small. It can go as high as you want though, but for what we need this for, we're only gonna go up to the perfect fifth powers, okay? So if you look right here, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, okay? Now 4 times 4 is 16. So then I have to multiply it by 4 again, and that would give me 64. Now 5 times 5 is 25, and then if you multiply by 5 a third time, that would give you 125. Now for your fourth power roots, basically you're just multiplying by 1 again. You're multiplying by 2 again. You're multiplying by 3 again. So you can just do that. You can use a calculator if you want. So 8 times 2 is 16. 27 times 3 is 81. 64 times 4, that would turn this into 256. So 4 to the fourth power, 4 times 4 times 4 times 4 is 256. And then 5 to the power of 4, you got to multiply this by 5. That will give us 625. Okay? And then with the fifth roots, it's the same idea. Now you're going to the power of 5, so you got to multiply by that base one more time. Okay? And so let's see, if you multiply by 1 again, that doesn't change. It's going to stay a 1. Okay? And then let's see, 16 times 2, let's see, what is that? That's 32. So 2 to the fifth power is 32. Then 81 times 3, let's see, that's 243, so 3 times 81, 243. And then 256 times 4, that's going to be 1,024. Okay, we're not, we're really not going to go past this chart. So you might want to keep this chart in front of you as we work through these examples. And then when you're doing your homework, and then especially for the exam, since it's open notes, you'll want to have this kind of handy to kind of help you out here. So the first one right here, 54, the answer is 3. And the reason why is because 27 is the same thing as 3 to the power of 3. And so when I take the cube root of that, the cube root is canceling out with the cube power, and that's where I'm getting the 3 from. Okay, number 55, pretty much the same as 54. This answer will be a 5. Why? Because 5 to the third power is 125, and when you take that cube root right there, the cube root nullifies the cube power, and we're left with a 5 right there, okay? Now, 57, you can take the shortcut that I showed you up here. When you're dealing with a negative, it could be a little bit more confusing, and I do want to kind of talk about this a little in depth. But the shortest thing to do is just go ahead. You can only do this when this is odd, though. Let me make this clear. It has to be odd. If it were even, you would just say, not real. But since it's odd, what you can do is you can pull the negative sign on the outside, and then now you can just focus on this part of the problem. So what to the third power gives you 8? That would be a 2, right? So this right here turns into a 2, and then you have the negative with it. So the answer is -2 right there. Okay? And so just to kind of, like I said, give you a little bit more of an in-depth look at this. Why is the answer -2? Well, remember, what you're trying to do is, let's say we're trying to figure out this equals, we'll call it b, right? So what this question is asking you is b to the power of 3 equals -8. That's what this is asking you right here. The index is saying your answer to that power gives you the value inside the radical, okay, the radicand inside here. So it's asking you what to the third power gives you -8, and it's got to be a -2, okay? So what happens here is a negative times a negative is +4, and then you have to multiply by -2 again, and that turns it to a -8, and so that's how you can check it if you like, okay? And so that's how that works. And so the thing is, as we get on to the next slide and stuff, some of these are going to be a little bit more complicated than, this particular example. So the best thing to do is just get that negative outside so you can focus on what's going on inside, okay? All right, let's look at 58. So right here it's saying, okay, what to the fourth power would give me 16? And the answer there is 2. Okay, because 2 to the power of 4 equals 16. So that's why 2 is my answer. Okay, and once again, you have that little cheat sheet up above. Okay, 59. Oh, I guess I'll just pull the negative out, right? Oh, wait a second. This is even. It's even. Whenever it's an even, you can't do even roots of negative numbers. Or it's not that you can't do them. It's just that it's going to be non-real. And like I said, at the very end of the lesson, we're going to actually finally get to see what we can do about that, okay? So it's not no solution, okay? It's not undefined, it's just non-real, okay? And so you could be like, well, why can't I do -2? Well, let's see what happens. If I do -2 times -2 times -2 4 times, let's see, a negative times a negative, that's positive. Negative times a negative, that's positive. 4 times 4 is 16, not -16. So even though I made the base negative, it still won't work, okay? So right now, we're just going to say non-real, and we'll take a little deeper dive at the end. Okay, so now what we're going to do here on the next couple examples is, we've done this before, we just haven't done it with anything other than square roots. So let me give you an example of where we've seen this before. We've done stuff like the square root of 20. And what we did was we broke it up into the square root of 4 times the square root of 5, right? And then that became 2 square roots of 5, right? That's basically what we're going to do here. The only problem is we're looking at our cubes. Okay, and these are all cubes. So let me write my perfect cubes down. So let's see, 2 to the third power is 8. 3 to the third power is 27, and so on and so on. I don't think I need to go past that for these first few examples, okay? So what I want to do is I want to break it apart like I did on this example up here, okay? I can break this into two different pieces. And 32 is not divisible by 27 evenly, but it is 8. So I'm going to break this up into the cube root of 8 times the cube root of 4. Okay, so remember, we're doing cube roots, not square roots. So you gotta kind of shift your mind there and think about cubes, not squares. Okay, so the cube root of 8 right here, we can see that that would be a 2, and then we're left with the cube root of 4 left right there, and that's your answer right there. That's it, 2 times the cube root of 4. Okay, so another example here, this of where we've done this before, but with square roots. So before we've done something like the square root of x to the power of 5, let's say, okay? And so what you have to do is you could break off 2 here, 2 here, and then you could have a leftover right there. So that's, if you multiply this back together, that's the same thing as x to the power of 5. And so see, the square root will nullify the square power. And I can do that on those, and then this one would be stuck there. X times x, that would be x squared, and then I'd have square root of x right there. So that's kind of a quick example of where we've kind of seen this before. The difference now is we have a index of 3. So I need my exponents to be powers of 3. So what I'm going to do here is I'm going to break this up into the cube root of x cubed. So I'm taking 3 of the 4, and then that will leave 1 left all by itself over here. So it has an understood power of 1 right there. Now this cube root will nullify the cube power, so that'll just be x. And then we'll have the cube root of x right here, and that's your answer. That's what we're looking at. Okay, just for fun, I'm going to show you one that gets a little crazy here, and then we'll look at 71 in a second. What if I had the cube root of x to the power of, let's say, 40, let's just say 40, okay? Oh boy, you know, you're not going to want to break that into x to the third, x to the third, x to the third. That would not be fun to break this up into a bunch of x to the power of 3's. So what you can do instead is figure out how many times 3 goes into 40. 3 divided into 40, let's see, goes 1, subtract 3, carry that down, I have 10. So 10 goes into 3 times. So let's see, that would be a 3 right there. Subtract the 9, that'll leave me with a 1. That's my remainder. So remainder of 1. Okay, so 3 goes into 40 13 times. So what that's telling me is basically I would have x to the power of 3 13 times, right? And so I could cube root that 13 times, and I'd end up with x to the power of 13. And then there would be a remainder of 1 left inside the cube root, so I'd still have 1 left behind. So that is my answer to my, I kind of made up an extra example right there, okay? So basically what you can do is divide the index into the exponent. However many times it divides into it, that's going to be your power on the outside. The remainder will be your power on the inside, okay? So that's just a little trick if the powers start to get large. And we might see a couple examples. I don't think they'll go up to 40, but I just wanted to give us an example like that. So, like I said, we'll get some more practice in a minute. Okay, now let's look at 71. So neither one of these are perfect cubes. You might be like, oh, that's a 3, right? Well, if it was a square root, but it's a cube root, so we can't cube the 9. Now what we're going to do, we've done this before, we're going to multiply them together. So they have the same index, so we can multiply them together. So this is going to be the cube root of, what is that, 54? Okay, now my perfect cubes, let's look up here. Let's see, 4 to the third power would be 64, so that's too big. 27, yeah, I think I can do 27. I think 27 will work. So I can break this into the cube root of 27 times the cube root of 2. All right, so the cube root of 27 is 3, and then I'll have the cube root of 2 right here, and that is my answer. That's my answer right there. Okay, let's see. I think I have a couple more on this next slide, and then we'll make a part 2 video for the last couple. Okay, so we got 3 more we're going to look at here. Okay, and so as you can see, these are going to be a little bit more going on here, and these are the ones that you really want to get down, okay? So we have an odd root, so I have a negative inside, so that's okay. What I want to do is I'm going to pull that negative out, and so then I'm going to have the cube root of 80, okay? So the negative got pulled on the outside. It's basically understood as a negative 1 right there, okay? And then I'm going to go ahead and give my variable its own little square root, okay? And so now I just need to look at each one individually, okay? So looking at my perfect cubes, so my perfect cubes, let's see, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64. Oops, writing off the page. Anyways, so I got to figure out how to split 80 up. So let's see, is 80 divisible by 64? No. 27? No. 8? Yeah, it's divisible by 8. So what we're going to do is we're going to break this up into the cube root of 8 times the cube root of 10. And then it's up to you how you want to deal with p to the 8th power. If you want to do my little division trick, I think that's probably the easiest way to do it. You just do old school division. I'll show my work though too, because I want to make sure we're understanding the concept. But basically 3 goes into 8 2 times with a remainder of 2. So coincidence, they're both the same. But basically what's going on here is you could break this up into p to the power of 3, p to the power of 3, so that's 6 of them, and then there's 2 left, so p to the power of 2, okay? And so let's go ahead and simplify this. So right here we can cube root the 8, so let's see, we're going to have negative 1 times 2, and then we have the cube root of 10, and then these I can cube root. They nullify the cube power, so that would leave me with a p and a p. And then I have the cube root of p squared right there. Now, anything that's not inside a radical sign, we'll go ahead and multiply together. So negative 1 times 2 times p times p. So I'll get negative 2p squared. Okay? Anything inside the radical, we'll go ahead and multiply those together now. So the cube root of 10 times the cube root of p squared. So we're going to put that all together. So that'll be 10p squared. So all that will go together right there. All right, so looking at the next one, pretty similar concept. So I'm going to go ahead and break this up. So let's see, we'll have the cube root of 54 times the cube root of p to the power of 7. And so let's see, 54 is divisible by 27. So I think we might have saw that on the previous page actually. So let's see, cube root of 27 times the cube root of 2. And then p to the power of 7. Once again, I like the division. If you want to do it differently, that's fine with me. Let's see, remainder of 1. So basically this is going to turn into p squared, and then the cube root, I have a p left behind. I have 1 left behind. That was my remainder, okay? So hopefully you kind of understand the idea of how that's working. You basically have 2 sets of 3, and you cube root those sets, and you get a pp, which then, when you multiply together, will get you the p squared, okay? So, let's see. Let's look at the cube root of 27. Let's see. That'll be 3, and then we'll have cube root of 2. Then we have the p squared and the cube root of p. And once again, just kind of clean it up. Put the 3 times the p squared next to each other, and then put the cube roots next to each other. All right. And let's see. All right. Let's look at our last one. So we are dealing with the fourth root, so we'll have to kind of look at that chart when we look at this one. So let's see, we've got the fourth root of 80, and let's see, I've got the fourth root of p to the power of 10, and we'll deal with the variable in a second. We'll use the division, it should be pretty simple. But let's look at 80. So I'm going to go back a page real quick. So I'm going to look at my perfect fourth roots. And so let's see, is 80 divisible by 81? I'm so close right there, but that won't work. But 16, yeah, you know what? 16 will divide into 80. So 16 divides into 85 times. So I can break this up into the fourth root of 16 times the fourth root of 5. And then I'm going to go ahead and do my little division trick for my variables. So I'm going to take the 4 and divide it into 10. And let's see, 4 goes into 10 two times with a remainder of 2. So once again, it's a coincidence that they're both 2, okay? So that means that a p squared comes out, but then also a p squared stays in. Okay, sorry, I know it's hard to see that. I'll clean this up in just a minute. So let's see, the fourth root of 16 would be a 2, because 2 to the power of 4 is 16. 2 to the power of 4 is 16. Then my fourth root of 5 is still there. Then I have my p squared, and then I have my fourth root of p squared right there. Now what we'll do is we'll kind of reorganize it. So we'll put the 2 and the p squared together. So 2p squared. And then we'll put all the fourth roots together. So the 5, and then that p squared right there. Okay. All right. Okay. So, really, we could have gone even further on these and did fifth roots and sixth roots. And your homework some of those might pop up. I try not to, but your homework is kind of randomly generated whenever you click on a question. So I did my best. So it is possible that you might see higher than fourth roots, okay? But hopefully you've got the pattern down so you can figure that out. If you are having problems, don't hesitate to send me an email through my math lab so I can see the exact example so that I can send you back a short video to try to point you in the right direction, okay? So that'll be the end of the first part. I'm going to make a video for part 2.